All right, here we are in chapter 4 on systems of linear equations and matrices, and this is section 7 on Leontief input-output analysis. So he was awarded the Nobel Prize in economics because of the impact his work in input-output analysis had on economic planning for industrialized countries. Now, this input and output analysis attempts to establish equilibrium conditions where industries have enough output to satisfy each other's demands in addition to final outside demands. Now, to illustrate the concept of this analysis, we examine an economy comprised of only two industries, an electric company and a water company. Now, the output for each company is measured in dollars. Now, electric company uses both electricity and water inputs in the production of electricity, which is the output, and the water company uses both electricity and water inputs in the production of water, which is its output. Now, suppose the production of each dollar's worth of electricity requires 30 cents worth of electricity and 10 cents worth of water. And further, suppose the production of each dollar's worth of water requires 20 cents worth of electricity and 40 cents worth of water. Now, suppose the final demand then, and this is from all other users of electricity and water, is 12 million for electricity and 8 million for water. How much electricity and water should be produced to meet its final demand? Well, if the electricity company produces $12 million worth of electricity and the water company produces $8 million worth of water, then the production processes would require, well, we just take zero point 0.3 times 12 plus zero point 0.2 times 8, which was going to be $5.2 million of electricity. And similarly for water is $4.4 million of water. Now, with the production requirements set there remains only $6.8 million of electricity and $3.6 million of water to meet the final demand. Now, to meet both the internal demands of production and the external demand of the market, both companies must produce more than just that final demand, though. And so they must produce exactly enough to meet their own internal demands plus that final demand. And so to compute the required total output for each company, we're going to say X1 is the total output from electric and X2 is the total output from water. And with that, then we can say, okay, well, zero point 0.3 times x1 plus zero point 0.2 times x2 is going to be our internal demand for electricity, and zero point 0.1 and zero point 0.4 is going to be the internal demand for water. So if we combine all of that together, what we're going to have is we're going to have a total output, which is our x1, x2 is going to be the internal demand plus our final demand. And so that's going to be kind of how it looks like. This is going to be our D, these are X's, and all that. And so what it looks like then in matrix form is we have this matrix x1, x2 is our kind of our input output matrix times x1, x2 times d1, d2. And this is what it looks like. And x is going to be our output matrix. And D is our final demand matrix. And M is our technology matrix, where, we have this much electricity input gives out this $1 of electricity. This much water input gives out $1 of electricity, and same with the electricity going to water here and water going to water here. And really, this matrix is the key one that we really are doing everything with. And so that's going to be kind of our matrix we're going to be working with. And so, kind of what I was reading there before, this technology matrix is our heart of our input-output analysis. And the elements in the technology matrix are determined as follows. We're reading from left to right and then up. So we're going to start with E coming in here. We're going to input E with electricity. So the input from electricity to produce $1 of electricity, and this is going out. So this much input to this much output, this much input to this much output, this much input to this much output, and this much input to this much output. And, so it took 0.3 input to get one out, 0.1 input to get one out, 0.4 to get one out, and 0.2 to get one out. Okay, so that's how it's going to look at. And what we want to do is we want to solve the matrix for X. And so X minus M times X is equal to D. And so what we can do is we can factor out an X, and we have I minus M times that X. And if we want to solve for X, we have to take the inverse of this and multiply it on the other side. And when we do that, that all depends on if we can take I minus M getting an inverse. If we can't get an inverse, then it won't work. But if we can get an inverse, then this is how we solve for X. So what we do is we take I, which is just the identity matrix. In this case, it's going to be 1 down the diagonal, 0 on the other sides over here. And we're going to subtract off our M. And so we get 1 minus the, whatever it was, 0.3 And then that's going to be our zero point 0.7. And then 0 minus zero point 0.2 is going to be minus zero point 0.2. 0 minus zero point 0.1 is going to be minus zero point 0.1. And 1 minus zero point 0.4 is zero point 0.6. And so that's how we get this. Then we use technology and we get our inverse. And then we take that inverse and multiply it by D, which is our demand, which is 12 and 8. And that gives us our X1 and X2. Okay, so that's going to be what they have to produce to be able to meet both the internal and the final demand. So in this case, $22 million of electricity and water has to be $17 million. Okay, so that's going to be how that works. Where a lot of this is all using just our calculator to solve for the inverses, and you actually could do that to do the subtractions if you wanted to as well. All right, so the input-output problem can be basically boiled down to this. So given two industries, C1 and C2, doesn't matter what it is, or it could be C1, 2, 3, depends on how many we have. Basically, we're inputting here, outputting here, input here, output here. Our output matrix is X, and our final demand matrix is D. And the AIJ is the input required to produce dollars worth for the output of whatever the matrix is, or the output is on top. So this input gives this output, this input gives this output. Now the solution is basically taking I minus M, find the inverse of it, multiply by our D, which is our final demand matrix, and then we get our X, which is our total output that we have to find. And again, this all is requiring I minus M has an inverse. All right, so let's stop with that, and then we'll come back with an example.